let's get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes
It's actually
in
a big
employee
piece
What is that process that a developer, or let's say a
As the
developer
Kubernetes ecosystem really boomed,
Welcome to another episode of In the Clouds. I am your host, Stu Miniman, and wow, we have reached August 2023. Before we get to our wonderful guest this week, I just want to a big thanks to the technology community. This last weekend, I participated in a charity bike ride. It's known as the Pan Mass Challenge. You might notice, up on my wall there is the PMC flag. It's the 5th year I've done this event. It is very well known, in the Northeast, and many around the country know it. It's the largest charity bike ride in the United States. I did a 2-day 162-mile bike ride. It was the first year that I had done the 2-day. I had done a bunch of 1-days in previous years. It was inspiring, it was tiring, and it was really good. I've raised about $8,000. Want to give a huge thank out to plenty of my work colleagues. I had people from Red Hat, from VMware, from AMD who donated. Those companies do company matches, and it's awesome there. Hey, next year, if you're interested in finding out more, feel free to reach out to me. We'll put a link in chat here. Anybody that wants to give any last minute donations, those are open. 100% of all the donations go to the Dana-Farber Institute, which is a wonderful organization, that nonprofit that does cancer research, cancer support. So really, really important event that I am, really happy to be able to participate in. So thank you for that. Let's switch gears. We have a wonderful guest this time. I'm happy to bring on the program Matt Butcher. He is the co-founder and CEO of Fermyon. I'm sure many of you in the cloud and Kubernetes space have heard lots of buzz about WebAssembly, WASM technology. And those of you in the container industry might remember Matt from some of his previous work. He's been pretty crucial in some awesome technology that we still leverage, in the containers and Kubernetes space. So Matt, thank you so much for joining me. It's great to see you.
Yeah, thanks for having me.
All right, so Matt, maybe if you could, I teased a little bit, but Helm charts, Deis, give our audience a little bit of your background.
Yeah, when my career started, I was really more focused on content management systems, and ended up working at HP in a brand new unit there called HP Cloud, originally to do the CMS system that ran the developer docs. And as soon as I got a taste of cloud computing, I was just all in. So switched from CMS into sort of the early OpenStack work, worked on platform as a service and OpenStack. And that really sort of redefined my career. And I got going right into the cloud world, ended up a few years later at Google. And then after a stint there, started at Deis, which is a small open source oriented company in Boulder. We were building a platform as a service on, at the time, this brand new technology that was so exciting. It was containers, right? And nobody else was building a PaaS on that yet. And then along came Kubernetes. We decided to re-platform our PaaS on top of Kubernetes. That required us going really all in on a technology that at that point was like 1.0, 1.1. And so we built a package manager for Kubernetes called Helm, and really got very involved in that ecosystem. That caught the attention of Microsoft. Brendan Burns had recently gone from Google to Microsoft and was interested in building really a top tier Kubernetes team. And so Deis got acquired by Microsoft. A bunch of us became sort of like the open source Deis Labs team inside of Microsoft, where we were, I had what I think was the best job ever, right? We were doing upstream open source all the time, going to all the conferences. It was just a lot of fun. Sometime in there, we started looking at, what might be the next generation, the next wave of cloud computing, and what kinds of things would sort of sit alongside the virtual machine and container ecosystems that had already taken such deep root in the cloud ecosystem. And that got us looking at, kind of the serverless style workloads, things that needed to start up and execute really quickly, go from start to finish in milliseconds instead of running for hours, days, or months. And that ultimately led us toward WebAssembly. A group of us left Microsoft back in 2021 to found Fermyon, really focused on building this kind of next wave of cloud compute. And our team's grown over the last couple of years. We're about 30 now. We do a lot of open source work upstream inside of Bytecode Alliance and CNCF and W3. And then, building Fermyon, the company.
Yeah, it's awesome stuff. I remember, boy, the excitement around the community, around Helm charts. It was funny. It was one of those things that just sticks with you, Matt, is certain announcements get really excited. And it was the first time that I remembered something getting removed that got everybody excited when they got rid of the tiller on Helm charts. The whole place just erupted and was like, yay, thank you. And it was like, somebody built that originally and we thought that was the right architecture, but absolutely we need to make changes. But, hugely useful. I think about, we still leverage, on the Red Hat OpenShift side, things like HashiCorp Vault, use Helm charts, and that's how we put them into the OpenShift ecosystem there. So hugely important. Thank you to that crew. So if you could, 2021, you started Fermyon. WebAssembly has been around since, it was announced in 2015. It launched in 2017. Could you, for our audience, just give us a snapshot? You talked a little bit about services, things, but what is this WebAssembly thing? How does this fit into this ecosystem of kind of the apps and, containers and VMs and everything, the web browsers, WebAssembly itself?
We could go all the way back to like 1996 to start that one, right? When Java was first invented and inserted into the web browser, the idea was we would have this full-featured programming language, and JavaScript was a little kind of dinky toy language that you use to kind of wire things up inside the browser. And Java, of course, took off in its own right in a very different direction from what everybody thought it was going to be. But applets, Java applets inside the browser, they sort of faded and fell along the wayside. And several other attempts were made to insert additional languages into the web browser with, Silverlight, with Flash, and each kind of had its day in the sun, but none of them sort of proved to have the longevity that we kind of hoped, right? When the Mozilla team in 2015 decided to take on this problem anew, they basically said, we've made a couple of mistakes along the way in this idea of embedding a programming language environment inside of the browser. The first one is every single time it was proprietary or supported by just one or two vendors. And the second one was we were always bringing a very specific language and saying, this is the language you can use in the browser alongside JavaScript. And so this effort began first with Mozilla, and then they quickly joined forces with the Chrome team from Google and at the time the IE team from Microsoft, the Safari team from Apple, and said, let's build a standard platform agnostic, OS architecture agnostic, language agnostic runtime that can go in the browser and that can just, instead of doing all the UI stuff initially, let's just figure out how to solve the core compute stories so we can, give those old C libraries new life by compiling the WebAssembly and running them in the browser. We can add some high performance or support some high performance languages like C and Rust and Go, and be able to have those running inside the browser to complement JavaScript. Great example of this in practice, right? Both Adobe and Figma use WebAssembly in their online graphical tools, Figma being a good example of a high-speed vector drawing program that you have in the browser. When you can compile C++ to WebAssembly, you can do very quick vector math and then be able to interface with those libraries from JavaScript. So that was really kind of the original vision. Us, coming from, at that time, Microsoft, and looking at serverless as the big problem, we were looking at something very differently, right? We did not start with WebAssembly and say, is there an application in the cloud? We started with this problem statement, and the problem statement went something like this. We need a cloud runtime that can run serverless functions really well. What are the problems we hear from developers that they want solved with serverless functions? First one is startup time. Amazon Lambda still, even today, 200 to 500 millisecond cold start time. We were looking for something in the 10 to 20 millisecond cold start time. We needed the cross-platform, cross-architecture. To really realize the idea of serverless, you can't really be telling developers, if you develop it on Windows, then you're going to have to run it in a Windows serverless environment. If you develop it on Linux, you'll have to run it in a Linux serverless environment. We really thought we could do, find an environment that would be more amenable to this kind of cross-platform thing. And then developer experience was a big deal to us, right? We just felt like the way, and we were at Microsoft, so this was an act of self-criticism at the time where we were going, we're asking developers to keep cobbling together very sophisticated systems, and we're just inserting functions as a service as one more piece that they have to, string together all the way through all the services. We need to figure out a way to make this developer experience really, really streamlined. So we started looking at technologies that we felt like would be good for that. And we played around with, very stripped back virtual machines and unikernels, and we tried out a number of kind of low level runtime technologies, but ultimately WebAssembly really bubbled up to the top. We looked at it and said the security profile that you need to run WebAssembly in the browser is almost identical to the security profile you need on the cloud side, right? It needs a strong sandbox isolation model. That's really important. We think about how much you trust your web browser to protect you from dastardly things that could be done by bad actors on the internet, right? That level of security was the same kind of thing. So that checked the biggest, most important box. But then as we got into WebAssembly and the cross-platform, cross-architecture, in nearly instant startup goals that the project had, it was just one after another. We were checking off the checkboxes on our wish list for this kind of cloud runtime. And that's, ultimately what drew us to it. And then what as we began to experiment, every single experiment was confirming for us, yeah, this is the right technology for it.
Yeah. So Matt, it's interesting. I think of some of the parallels, Docker didn't create containers, but they really helped, bring it out to the masses and make it there. Your team didn't create WebAssembly. Help me understand, what is the why and kind of the core capabilities that, your team have, and kind of the vision that you have of, what you take that existed and, where it will go from there.
Yeah, the Docker analogy is so good because I think, if Docker managed to cut a couple of years off of the adoption curve, that's the standard adoption curve, and they did it in a fascinating way. They had an operations-oriented technology, and they convinced developers that they wanted to use it, right? And operations teams are much happier when the developers come to them and say, we'd like to make, the operational experience easier for you because it's easier for us on the development side. So we really, we borrowed liberally from the Docker playbook in that sense and said, the first time I ran through the Lambda Hello World example, it took me 47 minutes. I actually timed it. And we thought that is a hard developer experience to sell. You want a developer to be able to sit down at the end of the day on Friday and say, I've got some time to learn something new. What's out there that I can learn? The last thing you want to do is have them frustrated because of all the little steps they need to take to get Hello World running before they can really experiment with it. And we said, okay, that's a hurdle that we can take on, right? Can we make the developer experience so good for serverless applications that they can do it in, 2 minutes. Let's get them to Hello World in 2 minutes. So that became sort of like a crucial story for us for our first year as Fermyon was, as a developer, I can get from a blinking cursor to my first deployed application in 2 minutes or less. And that we thought, okay, then we have a chance at articulating our actual value prop, which is we can run faster, we can remove a bunch of road speed bumps in the road to getting your application deployed. We can run cheaper. We can run cross-architecture, cross-platform. All of those stories really take a little bit of experience before the developer understands the benefit of them. But if we can just make the developer experience excellent, right, really awesome, then people will try it out and say, oh, well, just for this, I would like to use it. That I think is essentially what Docker did, right? Yes, you could build containers if you had, 4.5 hours to start assembling your container and get it all, figure out how you're going to package and distribute it. Or you could write a Docker file in a couple of minutes and then have something that was easily shippable and easily executable and testable. And that it was great that you pointed that out, because I think Docker's biggest contribution to the container ecosystem was showing how easy it could be for developers. And that's, the kind of thing we want to do with WebAssembly in the cloud.
Yeah, absolutely. So quick aside, we actually got a comment from the audience. They asked for your thoughts on Golem Cloud. They said Waza makes it possible. I'm not real familiar with it. It's something about decentralized computing and the like. But if that's one you can answer.
Yeah, I mean, and you'll see a number of attempts to figure out what parts of WebAssembly we can leverage. Golem hasn't been totally, they've got a couple of blog posts and I think it's still a closed source solution at this point. But part of what they're looking into is whether or not you can freeze and unfreeze WebAssembly modules. And this actually gets to a very interesting point about WebAssembly itself. As a bytecode, a stack-oriented bytecode format, you can do some very interesting things because you've got the encapsulated sort of the entire running unit in one nicely snapshotable stack. We played around with this with Docker for a long time too, because Docker is very similar. And there's been this idea for a long time that it might be possible to freeze, move, and unfreeze a Docker container, right? And I think there's a lot of interest in the WebAssembly community in general in that same idea. Can we freeze, move, and unfreeze a WebAssembly module? And the same issues that came up with Docker are going to be the same issues we run into with WebAssembly. If you open a socket and then move something over to another server, you might move the binary, but you also have to figure out a way to make it look transparent to the binary that the socket that you were on over here is open over here, and same with hardware layers and all of that. One very fascinating thing, though, one very fascinating application of this, and we use it with JavaScript and Python and .NET. The first stage of any interpreted language is to sort of load all the source into memory, parse everything, load everything, and then you start executing. So when we looked at this, there's a great project from the Bytecode Alliance called Wizer, W-I-Z-E-R, that allows you to sort of make an init step and then freeze your WebAssembly binary back out. And so, with something like a JavaScript runtime, you can load all the JavaScript into memory, snapshot it as a WebAssembly binary, and ship the pre-initialized one. So for some of these systems like .NET, Python, and JavaScript, you can actually, TypeScript for that matter too, you can actually speed up the startup time over a sort of native implementation because you can preload a bunch of stuff right up front. So, I think Golem, several other people were looking into, us included, we're all kind of looking into what can we do with that kind of snapshotting ability. What are the limits to which we can push it? Golem's got very aggressive limits. We tend to take a very pragmatic approach because serverless functions are our primary focus right now. And we know those aren't going to last for days, months, weeks, months, right? Those are going to execute in milliseconds to minutes. And so snapshotting a running application is less attractive to us than some others, but it's cool to see that work kind of happening in the ecosystem at large.
Okay, so Matt, help us understand a little bit. We're talking a lot at kind of the application runtime.
Yeah.
You mentioned Lambda. Does what you're working on work with any serverless? Does that bleed into kind of the container serverless things? Or VMs left out in the dust? Where do you fit with kind of that infrastructure layer that many of us deal with?
Yeah. So at the core, what we wanted to build was a set of developer tooling and a runtime for serverless applications. So what does a runtime look like for a serverless application? A serverless application is an application in which you, the software developer, do not write the server code, right? The thing that stands up a process, listens on a socket, manages the interrupts, all of that kind of stuff. Instead, a serverless application is one where your application code takes a request or an event, handles it, returns a response, and shuts down. So again, you're looking at the lifespan of a serverless function being, milliseconds to maybe 15, 20 minutes at the top end, right? So a very short running piece of code compared to a server, which is designed to start up and run for hours, days, months, and so on. So by focusing on just building that piece, and that's Spin, Fermyon's Spin open source project, we can provide the runtime for a serverless environment. WebAssembly happens to be the best binary format to execute these kinds of things, but that runtime can then be portable across a wide variety of environments. So Fermyon Cloud, for example, runs inside of AWS. We use the entire HashiCorp Nomad stack to run everything. Nomad's such a flexible scheduler that we had. It was a weekend project to write our first draft of a scheduler for WebAssembly. But we also support Kubernetes, so you can run inside of Kubernetes alongside containers. The Run WASI project that's inside of Containerd allows you to run WebAssembly side by side with containers. And we're working with Red Hat, we're working with others to make sure all the different kind of flavors of low-level container runtimes can also support low-level WebAssembly execution. And then you can run it locally. You can run it inside of Docker Desktop. Docker Desktop supports this. In each of these cases, really all you're doing is saying, okay, all we need to do is map the idea of executing a very quick serverless runtime to the idea of being able to schedule and route traffic into this particular environment. And so to that end, our goal is to make it possible to run this in just about any kind of cloud environment, any type of IoT environment, and locally.
Okay. You mentioned the Fermyon Cloud. So help us understand kind of the open source project versus, how you productize, what monetization does Fermyon have?
Yeah. And it breaks it easily into a two-part story, right? First of all, how do we build these kinds of applications? Spin is an open source tool that allows you to, very, very rapidly build a new WebAssembly based serverless function. So you basically type spin new, it'll scaffold things out for you. Spin build, it'll build it into WebAssembly. Spin up, you can test it locally. Spin deploy, it'll push it somewhere else to run it. And we have top level SDKs for JavaScript, TypeScript, Python, Go, Rust, and we're adding more languages as we go. But basically any language that supports the standard called WASI, which is one of the W3 standards for WebAssembly, we can execute those inside of Spin. So Spin is the open source, really the core of everything that we do. And you can actually go take a look at the source code at github.com/fermyon/spin and kind of dive into your heart's content. It's all written in Rust. But we needed a place to run these kinds of applications. So we built a reference implementation called Fermyon Platform that just takes a Terraform and installs. It can install into clouds ranging from, Azure and AWS to Civo and Equinox and wherever you kind of want to run your thing. That was kind of a reference implementation to show how one might run it in production. But we wanted to provide, one layer on top of that and say developers want the easiest possible way. And this is a big thing for us. How do we give developers the easiest possible way to do X? The easiest possible way to deploy your app would be, hey, I just type spin deploy and it pushes it out to somebody else's managed service. And I can, log into my dashboard and manage it from there. Fermyon Cloud is that. Right. It's a developer-oriented hosting platform that allows you to, with one command, deploy out there, and then you can log in there and map your domain to it and wire up some databases and whatever you need to do to take that thing from sort of like the idea you've got locally into a production environment where you can run it for everyone to see.
Wonderful. Matt, I appreciate how you, kind of explained all that. Do want to, give a mention. I know your team will have a big presence at WASMCon, September 6th, 7th, happening in Bellevue, Washington. So, Seattle, a great place to go for these things. And yeah, it's one of those because WebAssembly, it's been around for a number of years, but boy, I remember like a year ago, the buzz on it was really, really high. Expect, a lot of companies there, and it's not, one company that's driving this technology. There's a pretty big consortium. You mentioned a couple, we've definitely, I'm sure we've got folks from Red Hat side. I've been hearing, some of our people that work, on runtimes down at the operating system that are pretty excited. We've written a couple of blogs on how this fits into the overall thing that we'll be doing. So yeah, good.
Red Hat was one of the founding members of the Bytecode Alliance. They have been a tremendous influence in the WebAssembly ecosystem, now spanning years, right? And it is, WASMCon's really cool. We should give a shout out to the fact that CNCF has gone from, a kind of pre-day thing, the WASM day that was really oriented around how does WebAssembly work with existing cloud native technologies, to now a multi-day conference that's designed to be open and pull in a lot of people from the other areas of WebAssembly, right? There's still a huge number of people who write browser-based applications. There's an increasingly or very rapidly growing tooling environment. And when you think about what would be the weak link in the WebAssembly plan right from the beginning? Well, the weak link in the plan is, it's nice that you can have a runtime that can run any language, but you actually have to get every single language community out there to support your binary format. And an event like WASMCon is a great place to bring representatives from the Python community, the Kotlin community, the Swift community, all of these different programming language communities, into the same room to talk about the same problems and solve
Matt,
them.
if I remember right, I believe RussCon is also co-located, with the event. So that'll definitely, bring in people there. So definitely check that one out. CNCF, lots of events, really cool stuff. Of course, I'm sure there'll be a lot of that bleeding into the KubeCon show happening at the beginning of November also. I know Fermyon was there. You and I got to speak, a year ago at the KubeCon North America show. Awesome. Hey, Matt, you've got Fermyon Beyond, Fermyon Cloud, Spin, the open source project, recently had an announcement about a NoOps database. I believe key value was the discussion. So help our audience explain a little bit about the recent announcements and where you're expanding your offerings.
Yeah, absolutely. For us, again, going back to that, as a developer, I can go from blinking cursor to deployed application in 2-minute story. That was our first year. We got to the end of that year and said, okay, we can do that, right? Our CTO, Radu, is very proud of saying it's actually 66 seconds now. I can go from blinking cursor to deploy. But we started saying, okay, well, what are the other kind of speed bumps that are frustrating or annoying or that developers could self-report they could live without, right? And one of them was setting up a local environment that matched the production environment. And another one was wiring up services, right? Essentially an operational concern that many developers find themselves having to take on and become experts in something, or at least, proficient in something that they really don't have any interest in. So we listened to that feedback and we said, okay, would it be possible to just sort of remove some speed bumps out of that developer path? And what would be the first and easiest one to do? And decided that the easiest one was one that we learned firsthand in the early Kubernetes days, right? I remember as I was writing my first Kubernetes apps, right? I was one of those people who was like, hey, everybody, the future is stateless. Your application should not have any state in it, shouting from the rooftops, along with many of us who were early in that ecosystem. At the same time, wondering in the back of my mind, yeah, but I need to store state somewhere. Where am I going to store state? I mean, it's got to persist. And so, and of course, in the Kubernetes ecosystem, we learned how to operate databases inside of Kubernetes, and that story has long since been solved. But we thought as we got going on this developer speed bump thing, can we remove that speed bump? Because serverless's big advantage is that you can scale from 0 instances to tens of thousands of instances instantly, and then back down to 0 as soon as all the requests have been handled. But the way to do that is because every one of those functions is stateless. So nothing's keeping state request over request. So rolling out a key value storage system was the first and easiest step for us. Let's just make it easy to store key value. The API surface is tiny. So we built a local version into Spin, where if you're running Spin, you declare, I need key value storage, and instantly it's just there. You don't install anything. There's no processes to manage. It's just part of Spin. When you deploy to the cloud, we wanted that same exact experience there, so that I do a Spin deploy and something somewhere else in Fermyon Cloud provisions me a key value storage system that I never have to worry about at all, other than to write my API calls to get and set and things like that. That worked out really well. We were surprised at how quickly and how quickly users adopted it, and what positive feedback we got back about it, because it was just one thing they didn't have to worry about. Writing stateless apps felt like writing stateful apps because everything was just happening at the API layer. We realized along the way it's actually a better security story too, because there's no risk of credentials or tokens leaking. There's no risk of TLS certificates expiring, because all of that is happening in the host runtime of WebAssembly and doesn't bubble its way up to the user land. We got such great feedback about that we went, okay, well, what's next? Relational database. And we already had a local SQLite database because that's what we were using for key value storage. So we just said, okay, well, can we provide a highly distributed in-cloud SQL database that uses the SQLite API or SQLite dialect, essentially, and make it so that you have that same NoOps story between the local host, where they just have it, and a deployment out into the cloud where they just have it. And again, there's no connection string management, no TLS management, no user management, nothing. It's just a database that's there, and you can start writing selects and inserts. So we partnered with Terso, who had been working on a distributed SQLite flavored database, and rolled that out only a couple of weeks ago. And again, we're really early on that one, but still the feedback we're getting has been really overwhelmingly positive, that this is just one less thing the developer has to worry about. Now, very quickly, not all developers are going to be happy with the built-in version of it. It's great for writing quickly. Many people will find it great for running on for the entire lifespan of their application. But some people will want to have their own database and manage it, or their own key value storage and management and manage that. And so as we built this, we said there should be a clear, easy way for a developer to declare, or for an operations team to declare, hey, instead of backing this key value storage to the built-in one in Fermyon, back it to a Redis database. Here's the Redis database over here, and inject that as config into the application so that they have an opt-out. Same is true if you want to use Postgres or MySQL instead of SQLite. And we're excited about that because it feels like we're starting to make the right division between the developer concern, help me just write my code as fast as possible, test it as fast as possible, and get it deployed without a headache. And the operational concern, which is, hey, from day 2 on, this thing has to be rock solid, has to fit in with our security profile, has to match our operational considerations. And I feel like we're taking kind of those first steps toward being able to make that distinction clear.
Awesome. Well, Matt, I'm a little surprised. We're 30 minutes into the call. You were just talking about some of the challenges that we're seeing on the developer side. We have not talked about generative AI at all. So, you've got Series A in. I'm sure by the time you go to the next time, you've got to have that mentioned at least, every paragraph that you mentioned it in here. But no, in all seriousness, I remember back, a number of years ago, it was like, Docker, like everything that we talked about, Docker was in the tech space right now. Generative AI is all of the discussion, not only in the tech community. Matt, I said it's one of those few things that, like, normally when I, get family gatherings and they're like, oh yeah, Stu works on computer stuff. Maybe they know I do cloud stuff, things like that, but they're all playing with ChatGPT and some of the things like now. So help us understand a little bit, generative AI, is there a play? Does it tie into, what you're doing, what you're seeing?
Yeah. And I think you were totally right about the magnitude of the impact of generative AI. I mean, it reminds me of when my, parents discovered the first websites, right? Yeah. And they're going, hey, can I go to this WebMD place and look up, is it reliable? Am I going to get good information out of this? And now we're seeing the same thing with early AI, where my kids know how to use it. My parents know how to use it. Everybody asks me, when is it taking over the world? And sometimes they mean that in a good way and sometimes in a bad way. But it's a really exciting moment, right? And once more, it's super exciting to be in an industry that at this particular epoch of human history is like, the innovation curve is just so fast. So the bottom line there is, yeah, we all have to know about AI, right? AI is not, I think there was for many years when we talked about AI, we were talking about it as a problem that there would be a specific class of engineers. They would be AI developers, and they would be, doing PhDs in this stuff, and we would hand off work to them, and they would be able to do the work and give us back meaningful results. And for a long time, it really has been that way. And when it comes to the core of what's happening in machine learning and what's happening in neural networks, yes, those people will continue to be the ones who are driving the innovation. But when it comes to using, large language models and using generative AI tools, I think that's a full stack developer thing already, right? I think in a matter of months, we saw it go from specialist to everybody needs to know it. And that means that we're on the cusp of a set of tools that need to be developer friendly, that need to be easy enough to pick up and include in your tool belt alongside knowing how to write SQL, knowing how to use a key value storage, knowing how to use a cache, knowing what a proxy is, that kind of thing. WebAssembly seems to be peculiarly well positioned in this case, right? Because the core value prop, one of those first things that drew us to WebAssembly back when we were looking for what this candidate next wave of cloud computing would be, was this idea that we needed something that was going to be operating system neutral and architecture neutral. Now, at that time, I was naively thinking only in terms of CPUs, right? It should be able to run on ARM, should be able to run on Intel. But the technology that, the WebAssembly community as a whole has constructed runs in such a way that GPUs are no different, right? Or even running a workload on a GPU, switching it to a CPU and back to a GPU, is all of that can be done transparently, where the user doesn't, the developer who writes the code needs to know nothing about any of that. They just need to know, hey, when I write this inferencing stuff against this particular library, it's going to run in the environment where I go, and maybe it'll be slow when I run it locally and it's consuming my CPU, but when I deploy it remotely and it's running on an A100 GPU, it's going to be a lot faster. developers understand that trade-off and very much appreciate the fact that they don't have to think about it. So I think WebAssembly is going to be one of those core technologies that in many ways blossoms because by pure happenstance, it was addressing one of the problems that the sudden burst of energy in the generative AI space has indicated is actually a really important problem to solve. So I'm looking forward to the next year, as I think we'll see a lot of generative AI oriented tools that come out of the WebAssembly space. And think it'll be a really good area of growth here. May in fact be sort of the killer use case for WebAssembly in the cloud.
Awesome. Well, hey, Matt, we did get another comment. I think they were listening to what you were talking about, the NoOps database and the key value store. And they said, how does it integrate with other cloud services?
So the idea with Spin is that Spin itself should allow you to connect different backend services into your WebAssembly host runtime in a way that is transparent from the perspective of the developer's code. So the developer is writing code, it compiles to WebAssembly. WebAssembly is a neutral format that runs in all these places, but it runs inside of a host runtime. And the host runtime does two things. It executes the bytecode instructions, right? But the other thing is it can essentially inject APIs directly into userland and say, hey, you can run this call and it'll do this kind of thing. So that's how we do database, right? We expose the database layer through the host. And then when you're writing code, you're writing against an API in WebAssembly, and the host is doing the work of translating your inside code to whatever needs to run on the outside environment. So in that way, then, as long as you can standardize the interfaces along that host boundary, then everything becomes portable. So WASI, the WebAssembly system interface, is this whole idea that we should be able to write system interfaces, right, that talk between WebAssembly, a kind of pure format, and whatever the system provides. And so WASI is sort of like the linchpin that brings these two things together. The practicality of that means that when you take a host, a WebAssembly host like Spin, you can plug in different backends to that. And in some cases, it's a configuration. If it's something that we thought about and support already, like databases, then yes, you can just plug in your MySQL database configuration here or your Postgres database information there. In other cases, for more exotic things, it's the kind of thing where you actually have to write the host plugin. There is a big specification working its way through W3 under the auspices of Bytecode Alliance, who does all of the writing the specs and then doing the reference implementation. This spec is called the component model, and the component model describes a very clear way, almost like gRPC style, like way of articulating what a host provides and articulating what WebAssembly modules provide. And it allows you to sort of build up and expose different services in new and interesting ways. That will streamline this whole process. WasmCon, I expect this to be the #1 story at WasmCon is what are people doing with the component model and where is it going from here? Because it's such a powerful unlocking technology for us to building applications that frankly, we've not been able to build before because there just wasn't a technology analogous to this.
Yeah. All right, Matt. Last question I have for you. This space has been changing really fast. Give us your outlook. What do you expect to see kind of the next 6 to 12 months?
So there are about 3 different work streams that I think will really come to fruition. The first one is there are a whole bunch of add-on specifications to WebAssembly that are working their way through W3. Garbage collection is one. When the garbage collection thing lands, then a whole bunch of other languages will be able to port over very easily because they won't have to bring their own garbage collectors. There are all kinds of like low-level things like that where some incremental improvements in the specification will sort of amplify out through many, many programming languages, communities, and many capabilities. Second one is the component model that I just talked about. That one redefines the way we can create applications, right? That we can build sort of these aggregate applications. And it unlocks a really interesting use case. And that is, imagine being able to take a Python library, compile it to WebAssembly as a library, right? And then write some Rust code that imports the functions from the Python library. And then maybe it exports a couple of other functions. And then you can write a JavaScript function that calls into the Rust library. And you can the language is no longer relevant because they're all bytecode. They're all the same bytecode format. And they have this kind of standard way to expose imports and exports. And when that happens, I think then we really start to open up some potential where things like you can use NumPy from TypeScript and you can, pick your favorite parts of Go and use them from inside of Rust just by exposing these different components. That'll be a big game changer. And then I think that the third and last one is, we're going to see a lot of languages moving. I've been trying to sort of diligently track the language ecosystem. Rust and C moved right away, in part because Rust moved alongside the specification and C was the target language. But now we're seeing JavaScript, Ruby, Python, .NET, all of those are maturing. And then sort of this last wave of languages like Java and Objective-C and languages like that, I think are starting, Dart, Kotlin are all starting to build up some gravity and momentum to support WebAssembly as a compiled target.
All right. Well, Matt, it's been a pleasure talking with you. Last, bonus question. Tell us a little bit, Slats the cat, because, Docker had Moby, and I'll tell you, it's a nice T-shirt. Everybody always likes it at the conference to grab one of those. So, yeah, how do we end up with Slats the cat?
Slats the cat is a real cat. Ivan on our team has a cat named Slats. During the pandemic, the cat suddenly developed very, very picky eating habits. And so Ivan, would feed her a can of cat food, open it up and give her a spoon in the morning, and she would just devour it. Then he would go back to give her the same thing later in the day, and she would not eat it at all. And so he'd take another can out and open it up. And this cat was just so finicky. And so he kept a spreadsheet on his fridge, just trying to track and see if there were any patterns. At one point, I called him, in our one-on-one, he said, yeah, I went to the pet food store and bought one of every kind of canned cat food to see if there's any pattern at all to what she wants to eat and what she didn't. So when we created that Finicky Whiskers game, it was originally sort of a joke on Slats, Ivan's cat. And then Slats has sort of like taken on a life of her own, and we all wear the t-shirts and love the Slats character. And finicky though she may be, she's also really adorable.
Awesome. Well, hey, a cute story. Always love, bring the real life into what you're doing. So, Matt Butcher, there's, if you see this last comment, thanks guys for the amazing job you and your team's doing. Really great to catch up with you. Appreciate you sharing with our community what's happening. Wish you the best of luck at WasmCon. I'm sure our teams will be crossing paths with you. So thank you so much for joining us.
Yeah, thanks again for having me. This has been a lot of fun.
All right, and thank you to the audience. As always, please feel free to reach out if you've got guest topics that you want to cover. Summer's a little slow. A lot of people on vacation, so I apologize for not hitting quite the regular bi-weekly cadence, but definitely lots of cool things I'd like to do in the second half of the year. So until next time, I want to thank you. I'm Stu Miniman, and thank you for joining us on your journey in the clouds. Thank you.